right, ladies and gentlemen, I'm going a little bit out of order. I'm going to do lesson 4.7 before 4.6. Because we're going to take a look at what we call triangle inequality. And what we're going to do is we're going to use triangle measures to decide which side is the longest and which angle is the largest. And then we use that triangle inequality theorem to decide, does it actually even make a triangle? And I thought this followed up nicely to what we did in 4.5, where we started looking at, do we have a formula that can tell us what type of triangle it is? Now we're actually going to figure out, do they even make a triangle? So let's take a look at what that is. And so, theorem 410, and notice this doesn't have a name, which means this is a theorem that's specifically for this book, which is why I didn't necessarily like you memorizing numbers, but memorize and understand what's going on in here. So what it says is if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So, for example, if BC is longer than AB, 3 is greater than 5, then what that means is angle A, which is opposite the 5, is greater than angle C, which is opposite the 3. So if you kind of think about this, guys, I only have 3 inches it took to cover up this angle, to connect that angle. This angle took 5 to connect. So it would make sense that the A is a wider angle because I needed a longer segment to close those endpoints of the angle. So the larger my side, the larger the angle it was that it was closing. So that's our triangle, and this idea of this triangle inequalities. And then for 11, we kind of do the converse of that. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So if angle D is greater than angle E, then that means the side opposite angle D, which is EF, is greater than the side opposite angle E, which is the 40 degrees. So once again, if I have a small angle, I know I need a small connection. If I have a large angle, I know I need a larger connection. So now what we want to do is we want to take what we know and see if we can put angles in order. So we want to name the angles from largest to smallest. So when we take a look at this, I'm going to kind of color code some things. So TV is opposite angle U. And TU is opposite angle V. And then UV is opposite angle T. We go across the triangle. So when we go over here, it says TV is longer than TU. So I'm comparing my blue and my green. So that means angle U, which was my blue angle, is greater than angle V, my green angle. The angle opposite the 10 is larger than the angle opposite the 8. And so because TU, my green side, is larger than UV, that red side, that means the angle opposite the green, angle V, is greater than the angle T, the angle opposite the 4. So if I have to put my angles in order from largest to smallest, I'm going to start with my largest side, 10, and go across to that, and that's angle U. I'm going to go to my 8 and go opposite that, which was angle V, and then take my 4 and go opposite that, which is angle T. So if you can put numbers in order, ladies and gentlemen, and you can go across the triangle, you can put angles and sides in order. So that's exactly what we're going to do here in example 2. Put the sides in order from longest to shortest. So angle E is the largest angle, and it's greater than angle D. So angle E is across from DF, so that means DF is greater than FE. Angle D, this angle we put in blue, 57, is greater than, I'm falling behind on my symbols, is greater than angle F, is greater than 37, and 37 is across from this DE. So that means FE, that was across from the blue, is greater than DE, which is across from the red. So once again, we have to put these things in order. The way I do that, guys, is this gets kind of confusing to have all of there at the very beginning. So I'm going to take a look at this and say, okay, I'm going to find my largest angle. I'm going to go across from that, and that means DF is my longest side. I'm going to take my next largest angle, which is 57, and go opposite that. So that means EF is my second longest side. And then we're going to take my smallest angle and go across from that, and so that means DE is my shortest side. So which theorem was used in example 1? Well, if we take a look and go to a split screen with these things, example 1 was sides going to angles. And so we had sides in theorem 410. So example 1 used theorem 410. And so you'll have to possibly do that in your homework. So that's what you're looking at, matching up what the theorem said. Example 2 is using angles to sides. So if we go through that, angles going to sides, that's theorem 411. So our answer here for this follow-up would be theorem 411. So if they ask you what theorem in your homework you used, you're going to tell them either 410, sides to angles, or 411, angles to sides. All right? So let's take a look at what the checkpoint is. Checkpoint says to name the angles from largest to smallest. So you're going to start with your largest side, 17, take it across to an angle. So angle N is your largest. Take your next longest side, 14, go across to an angle. Don't connect it to a side, but connect it to an angle. So angle L. And then take the smallest side, connect it to your angle, angle M. So you need to finish, and we will check in class on Monday. Name the sides from longest to shortest. So we're going to have to take our largest angle, take that across, so HG is our longest side. We'll then take the next largest angle, which is the 45, and so JG is the middle side, and then take our smallest angle and take that across, and so JH. So the same idea here, go largest angle across, so you need to finish this now, and that will be a check in class. All right, so now what we have is this triangle inequality. And what the triangle inequality says is that if you take the sum of any lengths of two sides, it has to be greater than the third side. So I can pick any two sides I want. So if I take CA and AB, it has to be greater than that BC. If I take AB and add it to BC, it has to be greater than that third side, CA. If I take BC and add it to CA, that has to be greater than the third side, AB. So all of those combinations have to be greater. Well, that becomes a lot of work. So let's take a look at example 3, how we can use that. We're going to use that to decide, can the side lengths form a triangle? Explain. So I want to know, can 3, 5, and 9 make a triangle? So what I'm going to do is I'm going to take these two smallest sides and see if they add to a number that's greater than the third side. So that's the only check you need to do. Take the two smallest sides. So take the two small, and they have to be greater than the larger. Because 3 plus 5 is not greater than 9, they would leave an open connection. So this does not make a triangle. If we take our two smallest sides, 3 and 5, we add those together, they equal 8. And once again, there's not enough to cover that 8. They wouldn't come up and make an angle there. So this is not a triangle. But if we take a look at 3, 5, and 7, 3 plus 5, those smallest sides are greater than 7. And if you just keep double checking, 3 plus 7 and 10 is just greater than the 5. And the 5 plus the 7 is greater than the 3 combination. And so this one does make a triangle. So you guys have 3 examples that you need to do on your own to see if those side lengths can form. So you're going to need to try those combinations. Remember, start with the smallest. 5 plus 7 is 12. 12 is not greater than 13, so this would not be a triangle. So you need to finish 8 and 9, and we will check those in class.